Starting to record. Okay, so again, here's where you are. We are in the third week, so we moving right along. Our term will run from April the 5th to June the 11th. All right, so we talking about sequences. We talking about sequences and functions, and we are moving right along. Again, our goal is to be able to recognize a sequence, describe the rule that is being used on the sequence, and then use that rule to determine more terms in the sequence. And again, the standard is just a guide for teachers so that all teachers teaching this topic will be teaching the same thing. So for us, we just had our community meeting. We're going to do a warm up. We're going to review the types of sequences, and then we're going to talk about how how to find terms in a sequence that may be further down the line, maybe the 15th term or the 22nd term. And there's a formula that we can use to do that. And then we're going to do a little practice with the formulas, and then we're going to close. So that's the plan, and we'll see how far we get. All right, so here we go. The warm up. And this is why I asked you to bring paper and pencil. If a sequence starts 312, find the next 5 terms of an arithmetic sequence. And then explain how it could be made geometric and find 3 terms that way. And then, of course, 2 is the opposite. You're given a sequence, find the next 5 if it's a geometric sequence, and then how could it be an arithmetic sequence, and find 3 terms. So I have 11:01. Can we look at this at 10 after? 9 minutes? Is that enough? Too much?
Let me see.
Arithmetic. And definitely break out those calculators. Oh, that is not right. Ew. 12, 06, 15. Now, if you all get ready before that time, then I'm ready. Let's just start talking about it. And again, remember, we don't have to go in order. So if you want to talk about the second one first, that's fine too. All right, we're going to take about 2 more minutes. Then we're going to figure out what we got here. All right, anybody have anything? If a sequence starts 312, find the next 5 terms of an arithmetic sequence. So what would have been your next 5? Anybody got anything? First of all, if it's arithmetic, that means that we will be either using which operations, a what or a what, if it's arithmetic.
Addition or subtraction.
Exactly. So what are you doing here?
Adding, so it would be 21. Well, I added 9.
Absolutely. Absolutely.
30, 39,
Yeah.
48, and then 57.
Yep.
And to
Exactly.
make it geometric, you would just multiply by 4.
Exactly. Yep. So to make it geometric, you're going to multiply by 4. And then, what's your next 3?
It is, I think this was this one. 1 second.
Mm-hmm.
48, 192, and 769. I think that's for that one.
48,
192
192. Oh,
and 768.
yep. All right. So anybody who didn't get that, yep, that's what it would have been. So you would have in the first one, algebraic, arithmetic, excuse me. You know that you are either adding or subtraction, adding or subtracting, excuse me. And because this is increasing, you are correct. You are adding 9. And so those will be the 5 that follow. But if this were a geometric sequence, then you could use that same start if you were multiplying by 4, and then you would continue the sequence. So that just shows, depending on the start, it can be an arithmetic or a geometric sequence, depending on what you see.
Mm-hmm.
And in both instances, you will be correct. So now look at the second one. Now, this is a geometric sequence. So what's your operation? And what would be the next 5?
I multiply by 5.
Yep. So if we times 5, then what is your
25,
go ahead, I'm listening.
125, 625, 3,125, and then 15,625.
Okay. Yep. 625, 3125, and then 15,625. Yes. All right. So now let's make this arithmetic. So if it's arithmetic, then what are we doing?
I added by 4.
Add 4. Yep. And so the next 3 would be
9, 13, and 17.
yep. So again, doesn't matter how it is presented to you, your mindset stays the same. Good job, y'all. So here's the check yours. Okay. We added 9. These would have been the next 3. It is arithmetic. However, if we needed it to be geometric, we would have multiplied by 4, and these would have been the next 3 terms. In the second sequence, if it's geometric, the numbers are increasing. So you multiplying by a whole number 5. And then those would be the next 5. 25, 5 times 25, 125. 125 times 5, 625. Times 5, 3125 times 5 is 15,625. But it can also be arithmetic. And in that instance, we would have been adding 4. And the 3 terms to follow would have been 9, 13, and 17. Good job. All right, so we talked about the sequences. They both are a list of terms. They both can be increasing and decreasing. And then there is a formula for each, because what we've been doing is we've been finding those terms that are close to or no more than 10 terms of a sequence. But there are times when you may need to know a term further down in the sequence. So today we are going to look at these formulas that'll help us find a term. If it's arithmetic sequence, this will help us find a term further down in the sequence. And if it's geometric, this formula will help us find terms further down in the sequence. Okay, so we are going to start with arithmetic sequence. So here's an arithmetic sequence: 3, 7, 11, 15. So just like normal, we will find the difference, and we will find the next 3 terms. But even if we find the next 3 terms, we would only have 7 terms in this sequence. But C is asking us to find the 20th term. So now, do you sit and find 8th term, 9th term, 10th term, find 13 more terms until you get to the 20th? Or we had this nice little formula up here, and we can use this formula to help us find the 20th term. And the variables of the equation are these are the descriptions. So A always represents the first term of the sequence. D is the difference, and we find the difference here. And then N is the number of the terms. So for us, in this instance, our N is going to be 20. So let's see what we can do. Can we find the 20th term, or can we finish this slide? Can we do it before the class ends? So again, let's see if we can. So the sequence is 3, 7, 11, 15. The first 2 questions, what is the difference? How is the sequence moving? The second
Plus
part,
4,
all right, yep, go ahead, by 4. What's the next 3 terms?
19, and then 23 and 27.
Okay, so let me throw this in here. So we're going to do, we add in 4. Oh, get down here, girl. Okay, so sorry about that. I don't know where that 4 went. All right, so we are adding 4. The next terms. Oops, undo that. The next terms are, you said, 19, 23, and 27. What's the 20th term? Did anybody put the pieces in? All right, so let us go back here. Let me vacuum up. How about this? Take all of this out. All right, now we are going to move this text box up. Really? All right, so okay, so we're gonna back this up. All right, so D is the difference, A is the first term, and N is the term that we are looking for. All right, so now that's better. All right, so if the formula says, come on. All right, so the formula says that our term,
Oh,
X,
that's the equation. So it would be 3 and then 4
3 plus, yep, go ahead, 4. Go
plus
ahead.
4 and then 20.
Yep.
Okay.
Okay, so I'm going to put this down here. So this is saying to us that,
Oh, that's easy.
okay, so all we did was we put in the pieces. The first term is 3. The difference is 4. And our n is the 20th term, goes here. And now it's just a math problem. It goes back to add, subtract, multiply, and divide. And remember order operations. Okay? So now, so here are our pieces. We put in 3. 3 came from there because that's our first term. The 4 is blue because that came from our difference. And then our term is 20. We're just going to bold that up. Okay, so we are looking for the 20th term. So now it's just a math problem, ladies and gents. So, and again, try to line up those equal signs so that you watch the problem unfold. Okay? What's 20 take away 1?
19.
What's 4 times 19?
76.
What's 76 plus 3?
79.
So the 20th term of this sequence will be 79. Okay? And again, the pieces, you just replace n. Again, n is whatever we looking for. We looking for the 15th term, n is 15. But here, we're looking for the 20th term, so n is 20. So our first term was 3. The first term of the sequence goes there, plus whatever the difference is. Our difference was a positive 4. So we just wrote 4. And then inside the parentheses, we do n minus 1. Well, our n value was 20. So this is how the equation would start. And then we just used order operations. We solved what was in parentheses, kept everything else. Then we did the multiplication, kept everything else. And then lastly, we did the addition. So we found that the 20th term in this arithmetic sequence would have been 79. And that is a lot easier than you going 27, 31, 35. Okay? You came right to the 20th term. Does that make sense?
Yeah, I get that.
Okay. So, and it took us right to our time. I know some of you have Spanish. So I thank you all for coming. I'm going to just stop the record.